I hope everyone is doing well. I am Strish. Thank you for joining me for this video where we are examining this. Why is the square root of -1 equal to an I? You learned this, you know it. We're asking the question why. When we are looking at something like this, square root of -5, we know we have a I root 5. The minus comes out as an I. If I have here a square root of, let's say, -4, it'll come out as a 2i. This is coming out as a I, this is coming out as a 2. We have a 2i. But why is this negative coming out as a I? Let's examine it. We have a certain complex number which is represented by a plus and minus bi. This is a complex number representation, a real part of your complex number and the imaginary part. When I'm looking here at this minus representation, what is my complex number? My complex number when I'm looking at this is specifically -1. But if I write it out thoroughly, I'm looking at -1 plus and minus 0i. When I graph this out on a complex plane, I'm looking at a -1 comma 0. It's a point which lands right over here. A complex plane representation, we know that the distance from the origin to here, which is your r, your modulus, is equal to a 1. We know the angle from 0 up to this right here, the argument is equal to a pi. When you bring this into the polar or the trigonometric form of a complex number, we have this z is equal to r, and then you have a cosine theta plus I sine theta. This right here is your polar form or the trigonometric form of a complex number. This form converted into that, well, you know what you have over here with regards to -1, which is my complex number. It is equal to 1 cosine pi and plus I sine of pi. That's what it is. That's the polar form of this number -1. Now what we are looking here at is root of -1, which you can write as -1 to the power of 1 over 2. Now we're suddenly looking at a power of a complex number, and we have a formula for that. If you think about the de Moivre's theorem, the powers of a complex number, we have a formula. The power of a complex number is equal to the modulus raised to that value n times the argument, which has cosine n theta plus I sine n theta. The power has come here as the exponent of your modulus and as values affecting the angle with which the trigonometric functions are applied to. The argument has the n value and the modulus has the n as an exponent. And what is n over here? N here is equal to 1 over 2. Bring this representation with regards to what you see over here. We're looking here z to the power of n, but here particularly we have z to the power of 1 over 2, which we know is -1 plus and minus, or we can just say plus 0i to the power of 1 over 2. When you bring this de Moivre's theorem with regards to what we have over here, we can bring everything into the template. I have 1 to the power of 1 over 2 times cosine n, which is 1 over 2 times pi, plus I sine 1 over 2 times pi, and then we close it out. When we solve it, we know we are looking here at our complex number z to the power of 1 over 2, which you know is all of this right over here, which is same as this right here, is equal to 1 to the power of 1 over 2, which is 1 cosine pi over 2. Pi times 1 over 2 is pi over 2 plus I sine pi over 2. Cosine of pi over 2 is cosine of 90 degrees at 0. Sine of pi over 2 is sine of 90, which is a 1. This is equal to 1. It multiplies with this I, which multiplies with this 1 over here. So my complex number, which was really what we were looking at, is -1 to the power of 1 over 2, which was root of -1, is equal to this I times that 1, which is equal to I, and it's done and it's shown. And now we know why square root of -1 is equal to I. We have utilized here the de Moivre's theorem, the powers of a complex number. I've converted a square root into an exponential form so I can utilize this formula. And that right there is the end. Thank you.